Welcome back to DellyMaths Concepts. We're looking at the special right triangle, one of those 45, 45, 90 right triangle. Now we're going to be finding these missing sides without using a calculator, and we're going to leave our answers in radical. Calculator, no trig ratios. And we want our values in radicals as best as possible. Now, let us take a look at what the 45, 45 special right triangle is about. So let us just draw a quick one right here. So here is my right triangle. Now, if this is 45, then this other third angle has to be 45 degrees as well, because if we should add all of these angles together, we should get a total of 180 degrees. So definitely, we call this a 45, 45, 90 special triangle. Why is it special? It's an isosceles triangle where if this side is x, this side is also x. You could see the base angles here being equal as well. So it's a special right triangle. It is also isosceles. Now, how do we use these to solve problems? Well, as we could see here, I'm going to use the Pythagorean theorem just to establish the idea. So the Pythagorean theorem would have stated that this side across from the 90-degree would have been the longest side. We call it the hypotenuse side, right? So let us say I'm calling that side C right now. What's a result for C? C squared is equal to x squared plus x squared. Now, if we keep working this, C squared is equal to 2x squared. And then C, if we take the square root of everything in an effort to find C, we're going to notice that we're going to have the square root of x squared times the square root of 2. The square root of x squared will give you x, but the square root of 2 remains root 2. So what it means for what we're about to do in this problem is that we're noticing something unique. What we're noticing is if I have the two shorter sides, any one of these that I have, if I multiply it by root of 2, it's going to give me the hypotenuse side. So that's the idea. Any short side times the square root of 2 will give us the hypotenuse side with this special right triangle. How does that transform to here? Well, let's take a look. We're supposed to find A, we're supposed to find B. For B, we could already put on what B is because this is 45 degrees, which means that this is 45 degrees as well. These are base angles, all right, because it's isosceles. Therefore, the value of B would be the same as 2 root of 2. So let's put that on. So B is equal to 2 root 2, just like this other side that we got from the beginning. Now, I want to find A. A is my hypotenuse, which is related to what I'll call C here. So A is going to equal to take any shorter side, which is this value, and we're going to multiply that by the square root of 2. As you could see, what we're going to have here is 2, and when the square root of 2 is squared, so basically we're going to have the square root of 2 squared, it's going to, well, so a square and the square root would have canceled, so we have 2 times 2, and it's equal to 4. The value of A is equal to 4. Now, let us take a look at another problem. All right. So in problem 2, here, as you could see, we want to find X, we want to find Y. Now, in this case, we actually have the longest side. And so because we have the longest side, what we're going to do is that we're going to go the reverse. If we divide the longest side, because remember, if you have a short side, And if you multiply any short side by the square root of 2, it gives us that longest side. That means if I have the longest side, all I have to do is to divide it. So you could see the principle that I'm going to execute here. If I want to find any one of my short side, I divide the longest side by the root of 2. So basically, x can be found by having 4. Then we divide this by the square root of 2. Now, we're not going to leave the square root of 2 in the denominator. Hence, we're going to rationalize, which means I am going to multiply the numerator and the denominator by the square root of 2. Let's look at what we have at the numerator. We're going to have 4 square root 2 at the top, but at the bottom, when the square root of 2 times itself, it's going to be resulted 2. And at this moment, you could see that we could cancel 2 into itself 1 and 2 into 4, 2. So here is the answer. 2 square root 2 is equal to x. Now, if we put this here, this is what we have. But remember, if this is 45 degrees, this is also 45 degrees since we're dealing with a right triangle, which means it's isosceles, where y is going to equal to 2 square root 2 as well. So y is equal to 2 square root of 2 as well. Let's take a look on our third problem. All right, so in our third problem, we're finding x, we're finding y. Again, I'm going to label the other 45 degrees right here. So we're looking at an isosceles again. It's the 45, 45, 90 degrees triangle, right? Now, the x is the longest side. That is my hypotenuse. So it means then I could easily just tell the value for y. Y is equal to 3 square root of 2 all over 2 right now. How do I find x? X is the longest side. So remember now, if I take any short side, in this case, if I take any short side, which is 3 square root of 2 all over 2, if I do multiply this by the square root of 2, it is going to give me the longest side. Now let's just bring this up. Now we have 3, and then we have the square root of 2, and it's going to be squared. This is all over 2 times 1, which is 2. At the top, what we have is 3. When you square a square root, then the square and the square root cancel. We're left with 2 all over 2. The 2 could cancel itself one time. So x is equal to 3. All right. So there we have x, we have our y. So problem number 4. Again, we have a shorter side. This angle here is 45 degrees because we're seeing the 90 there. So we have definitely, it's a 45, 45, 90 special triangle. This is a short side. That means y is also 3 square root of 2. So we're looking at this side here is this. To find x, it goes again, we're going to multiply any short side, in this case, 3 root 2. We're going to multiply this by the root of 2. Now, 3 times the square root of 2 square, 3 times 2, x becomes 6. Thank you for watching DellyMaths Concepts. Like this video, share it, subscribe to the channel, and stay tuned. We will be looking at the 60, 30, 90 special right triangle in our next video. Bye-bye.